Good morning. My name is Pratik and I'm here to present my assignment 3 for Big Data Technologies. As you can see from my screen, I have opened a GitHub link right now which I had uploaded whole assignment in this GitHub. I have already posted this link through which you can navigate to my GitHub repository, and going ahead after this recording I will be adding a YouTube link also in this particular GitHub file, in this particular notebook file specifically. And the contents are pretty specific to the task which were given to us. For better navigation, I will shift to VS Code, and through which I will able to explain you what I have done so far. As I told earlier that I have divided the contents according to the task. Task 1 was to load the data and have a comparison between all the data which we have. That is Yellow Taxi New York data for 2023 for the month of January, March and June. Here in the first, I have loaded the data and I have only populated first 10 columns of this particular data. After loading the data, and I would also like to share that I have a main file which I am using that to get that particular data set. So in here I have a frame which will get that particular January data frame, which will get a March data frame, which will get a June data frame, and I'm using this particular main.py file to get all those data frames basically. Now in terms of comparison, I have identified three comparison in which I will be doing. One is my trip distance, second is my payment type, and the third is going to be my trip duration. So going further ahead, in my trip distance, as we can see according to this graph, for January, March and June, the trip distance is increasing with time, basically with pickup time. This is because people do take longer during the day trips because they have work and everything is going on. And we can also observe, like, moving further ahead in the year, the trip distance is continuously increasing. The longest trip is during the middle of the day, which is, I'm guessing, 10 a.m. to 4 p.m. and the shortest trip is early mornings and late evenings. Now coming to the payment type, we are given in the data analysis that there are total 6 type of payment type, which is credit card, cash, then no charge, then we have a dispute, payment time is unknown, and then there was basically a void trip. It was no trip at all. We can see that most of the payment type is in credit card and cash, as you can see in here also, credit card and cash. The most common one is credit card, then it is followed by cash, right? And then the number of trips is increasing over the time also, like the payment of those number of trips is increasing over time. We can also see, like, few of those in the month of March and June we have no payment at all. So far it is unknown, basically not no payment, but it is unknown. So, and there are few others which are in dispute also, yeah. Coming to my third trend would be trip duration, like how long was the trip basically for all these 3 months, and where was the trip exactly. So here is the trip code, which is like standard rate, JFK airport, New York, and negotiated fare. These are all the code through which we can see what was the exact, where did the exact taxi or the trip go to. We can see that it is increasing as it was increasing for my trip distance also. So trip distance and trip duration is kind of similar, because obviously the distance increases, the trip is also increasing. The distance of the trip is also increasing with the distance and duration of the trip. Going further down to my second task, which was exploring of data, I did see that there were like around about 71,000 data which are null values or which are none values. So I go ahead and total amount of data was around about 30,000. But I took the liberty of just deleting those data first of all the missing values which are non values, and then I did check for the customer count, because if there are no customers in a cab, then there is no reason for a trip to happen basically. So for that, when I looked for a passenger count if is equal to 0, I got like there are 51,000 entries with passenger count 0. I dropped those columns also. Now there was many noises in the data, as when I was analyzing and comparing this data, I did find like there are a few data which date back up to 2010 or 22 instead of 2023. So I did ignore those kind of data, but in terms of noise and noisy values, I only took two, which is passenger count, as I talked about earlier, and the trip distance, right? So passenger count, the cab can only hold up to 4 passengers, right? And up to 4 passengers, or maximum up to 7 passengers. So I tried to get those number of data. Like my logic was that, okay, if it's more than that, then it's an invalid value, it's a noisy value. Same as trip distance. So there is a particular distance to which a cab can go or a cab can travel. It cannot travel cross country, or it cannot travel certain particular miles. So I put a limit of 1,000 miles, and then I got a distance of that. So here I have the output of it, that what is exactly my data. While doing this, I did encounter that we have few amount which are in negative, which is a big noisy value. You cannot have a data set, or you cannot have a amount in negative. So this is one of the discrepancies which can mislead our analysis. I took the liberty of converting them into absolute values. All this amount value, basically fare amount, extra, tip, toll amount, and total amount, which can mislead the data. So I did this whole conjunction of that, correction of that, sorry. And after that, I ran a correlation which might give me good statistics or good value of the correlation. The highest correlation which I got was between the total amount and the fare amount. Obviously, if the fare amount increases, the total amount will increase, which is like much more closer to 0.98, which is 98%. That is like a really high correlation. In terms of featureization, I added a logic of rush hour, since many people like to work 9 to 5 or 9 to 6. So I did put an analysis like trip flag, like if the cab is booked between 9 to 7, then it's a 1. If it's not, then it's a 0. We can see the trips in rush hour is way too high than compared to not in rush hour. In terms of looking for the location, pickup location and drop off location, like how what is the straight line, and what is the difference between that, I used the square root formula between the two coordinates to have a straight line, and then compare that to the trip distance. Here you can see I have compared that to a trip distance. Further ahead, pick off and drop off frequency. It's just like how many times a customer was picked off and dropped off from the same location. So we can see that this particular value is the highest of pickup of drop off frequency, basically. In terms of data analysis, which is my fourth task, I ran to the vendors. So vendor 2 looks like the most popular vendor in terms of doing cabs, using cab services, or like hiring the cab services. The peak hour of travel is 18, which is 6 o'clock, when after your meetings or after your work you want to travel somewhere out after you are done with your work. So that's the peak hour, and we can see that the peak hour is between 6 to 5, which is when every work is closing, every work is done. That's the peak hour of traveling. The average distance is the same logic which I have done for all of the above. For pickup frequency, I put a I check the date, whether it's a weekday or weekend. After having a checking a weekday and weekend, I grouped them together with the frequency, and I got that the Sunday is the most days when people do take trips, when people do take cabs. Maybe they are going somewhere, or maybe they're coming back from a vacation, something like that. Average number of passengers, I had to round this up basically, because you cannot have 1.5 or 2.5 passengers. So it's like one is, you always have one cab driver, so 1.5 is closer to 2. But yeah, average number of passengers is always 1, because we include excluding the cab member. The correlation between the fare and the tip is so you can see that the fare amount is 9, but the tip given to that is 135. Further going down ahead to the conclusion, to end this, the challenges, basically I would focus on the challenges more, because there were a lot of missing data. There were as I mentioned earlier, there was previous year data included with that 2023 year. There were negative values, there were zero values. The data is very large, so it is very hard to handle the data. You have to migrate it into cloud platform. And that's all. Thank you.